So hello guys, my name is Edson. Welcome to another STM32 FreeRTOS session, and today I'm going to look at how you can achieve inter-task communication. It is very hard to find a system that has parallel tasks that do not depend on each other. At some time you may need to share some data to a task for processing, and I'm going to do that using queues. And for demonstration, we just have several LEDs starting from green to pink, and they will be connected from pin PA5. There are 5 LEDs, so P5, P6, P7, PB6, and PC7. So I'll have two tasks. That one task will send data to the queue, and also the other task will get data from the queue and execute the commands, and the LEDs will blink according to the commands that we shall send to the queue. So the queue sends the data through the handle, that is the queue handle. So we shall also see how we can create that, and I'll just go ahead to my cube MX, and then I create a new project, and I'll be using Nucleo F401 RE. So the first thing that I want to do here is clear all the pinouts. So I'll have pin PA5 will be connected to red LED, so I'll give it a label red. Then PA6 will have the green LED, so give it a label green. And then PA7 will have the blue LED, and then PB6 as output we'll have the yellow LED, and finally we have PC7 that will have the pink LED. Then finally go to system call, RCC. You can enable the external resonators, and also you go to syst, you change the time base to any timer apart from SysTick, and then finally go to middleware and FreeRTOS, select version 1, and since there will be one task that will be generated, you shall just go to task, and then we shall give this task receive. This is the task that will receive data from the queue, so I can have it as receive task, and I'm going to give the same name to the entry function but with an underscore. So just say okay. Then finally you can go to call configuration, then it's okay for me. So go to project manager, and then give your project a name. I'll just give it X task queues, and then I'll be using KEIL UVision, so select MDK arm, and then generate code. So before I open project, I'll go back to pinout and configuration, and then in the system call, go to GPIO and enable the pull down resistors for the LEDs. So select pull down, then can finally now generate code. So I'll finally go ahead and open your project, Then from there you can go to application user code, open the main.c, and first you can build your code. So the code has built successfully. So the first thing I'm going to do is create another task. So use OS thread ID and call it receive task. So we already have the receive task. So this is the send task, send command handle, and then we can also have a variable of base type return value of send function. So send task, go to user code begin FreeRTOS threads, and I'm going to have these return value of send is equals to x task create. So this is the function to create the task, and the first parameter is the function, so we call it the send underscore task. Then we can have the same name, and then can have the stack size of that function. Then we pass a null pointer, and then we have priority as above normal, so you can have always priority above normal. And finally we have the handle to our task, so we have the send send command handle. So then from there we have to go ahead and test whether it was created. So we use assert parameter, and then we check whether the returned value is equals to pd pass. Then from there we are going to define the task. We create a prototype for the task, so void send tag, and then void pointer argument, and then we are going now to define this in user code begin for. Then we have to create the while loop for. So then so far so good. So the other thing we are going to do is creating a queue. So just go ahead in user code begin private variable, and we can have a variable of queue handle t, and I'll call it led command handle, and we just have to copy that and in the user code begin FreeRTOS queue. So equals to xqueueCreate, and then the first parameter is the number of values that you want to hold in the queue. So we can hold 2, it's okay. And then the other parameter is the size of the data type that you want to send. So we are sending you int 8 underscore t. And then we should also check whether this was successful, and then we shall use assert parameter led command if it is not equals to null. So that's okay. We can also have this not equals to null. So then from there we shall go to one of the tasks. I'll go to the task for receive, and in here I'll create a switch case. So I'm going to have switch choice which I'll declare here as int or int 8 underscore t equals to 0. And for this case, I'm not going first to use the queue, so that I want you to understand why queues are important. So after this switch, you just have to open the curly braces and now say case 1 break. Just have to write the cases. I have 5 LEDs, so I need 10 states because every 2 states you have on and off for each LED. So let's see. So you have case 1, case 2, case 3, case 4, case 5, 6, 7, 8, 9 and 10. So that will be okay. 9. So then from there I'll have to create an enumeration type for the LED commands. So just come here to private type def, and I say type def enumeration, and I have these as LED commands, so LED CMD. So inside here we have the first LED is red, so we have red on is equals to 0. Then we can have red off, then green on, green off, blue on, blue off, then yellow on, yellow off, then finally you have pink on, pink off. So we can have these as 1 so that it can start 1 to 10. So then from there we go to the task, and we can have here HAL, GPIO, right pin, and for the first case 1, so we have red pin, and then GPIO pin set. So I can copy this for the second case, but in this case now it will be reset. Then I can have these, and instead of red I'll have green, and then green pin, and then I can have this in 4, but now you reset. Then from there we have the blue, then you have the blue pin, this in 6, now the it will be reset. Then we have 7, we have the yellow, just that, then we have the yellow pin, and you can copy this in 8, but now reset. Then from there we can have pink pin, and for the 10 I'm going to have it reset. So from here I can increment choice. So just come here and increment choice, and have a delay of 1 second. If choice is greater than 10, you can have it back to 1, so choice equals 1. So allow me to change this to 1, Then from there I think we can go ahead and build our code to see whether we have any errors so far. So we have no errors. So when I load this code to the board, we expect to see the LED going on off from one LED to another using the switch keys without using queues. So I'm going to go to debug, then settings, and I'll change this to reset and run. So let me load the code to my board, and you can see that now we have the control of LEDs using the switch keys. But now I want to share these commands using queues. So I'll go ahead and delete the choice, the if to check for the number of the command, and also the delay and the choice increment. And inside the send task function, I'm going to have xqueueSend, queueSend, and this guy takes several parameters. Is the handle that you want to send, that is the queue handle. So we have the LED command handle. So I'm going to have to declare a variable called uint8 underscore t command. So end command. Then the other parameter is the time to wait. If the queue is full, you have to give it some times to be empty so that you can add more data to the queue. So we can have to wait for the maximum delay. So we have that, and I'm going to test this. So if command is greater than 10, we can have it back to 1, and we can have we can send the queues after some time. So we can delay this, so vtask delay, and we can delay for 1 second. So this is the function that will control the blinking of LED. So inside the receive task, I'm going to use a function if queue receive, and we are receiving from this handle, the LED command handle, which is of type queue handle, and then we want to store some data inside the choice. So I'm going to have a choice. We can initialize this to 0, and we can have end choice, and then we can wait for maximum time, so by using port max delay. And if it has received the command, so 3D pass, then we are going to switch now the choice. So I'm going to have that. So let's build this and see whether it has errors. So it has no errors. Let's now load the code to our board and see what we shall have. And we can see that only one LED is blinking. So the reason why this is happening, we have not incremented the command. So I'm going to increment the command here. So let's now build the code and now load the code to our board. So you can see now we are using queues to send data to the queue. Then we receive from another task, and that is how you can achieve intertask communication using. So you notice when I reduce the time here, you also observe that when the code is running, also the blinking time will increase. So let us see. So load the board, and you can see that now it's a bit faster. So thank you guys for following up with me, and in the next tutorial I'll be showing you how to send data structures or how you can send values by reference. So I'll see you in the next tutorial. If you like this video, go ahead and subscribe for more, and please don't forget to share, and if you have any question, leave it in the comment section. Bye.